Mid-1944, over the vast empty Pacific, something is deeply unsettling the combat pilots of the 475th Fighter Group. A civilian is flying with them, a 42-year-old technical advisor in a P-38 Lightning. After grueling, long-range missions where every drop of fuel is a lifeline, he returns with his tanks inexplicably full. While veteran aces land on fumes, his fuel gauge seems almost frozen. For men who live and die by their calculations, this wasn't just impressive, it was impossible. Who was this mysterious man, and how was he rewriting the rules of aerial warfare? That man was Charles Lindbergh, the most famous and, by 1944, most controversial aviator on Earth. A pre-war isolationist and fierce critic of the Roosevelt administration, he had been personally barred from military service by the White House. Officially, he was just a civilian technical representative. This is the story of how that political outcast, operating under a secret arrangement with frontline commanders, taught American pilots to dramatically extend the reach of their fighters. But to understand why they would risk their careers to listen to him, we must first confront the crisis they all faced: a tyranny of distance. By 1944, the American war machine was pushing across the Pacific. But a map of this theatre is a map of water. The strategy of island hopping was a brutal logistical nightmare. A war fought not just against a determined enemy, but against the sheer, unforgiving scale of the ocean itself. For the Army Air Forces, this was a problem of range. Their primary long-range escort fighter, the Lockheed P-38 Lightning, was a technological marvel. With its twin engines and devastating firepower concentrated in the nose, it was a formidable opponent. But it had a critical vulnerability in the Pacific: its thirst for fuel. The flight manual, the pilot's Bible, was written based on experience from the European theatre. The doctrine was clear. For maximum engine performance and cooling during a potential dogfight, pilots were to fly with high engine RPM, around 2,600 revolutions per minute, and a rich fuel mixture. This kept the powerful Allison engines ready for instant maximum power. It was a procedure designed for the short, intense scrambles over France and Germany. In the Pacific, it was a death sentence for endurance. On long-range escort missions to heavily fortified targets like Rabaul, the consequences were devastating. P-38 squadrons would accompany the B-17 and B-24 bombers, pushing hundreds of miles over open water. But then would come the moment of truth, the point of no return. This was the calculated point on the map where the fighters had just enough fuel to turn around and make it back to their base. They would peel off, leaving the bombers to fly the final, most dangerous leg of their journey alone. Japanese fighters taking off from nearby airfields with full tanks would then rise to meet the now undefended bomber streams. The cost was staggering. Bomber losses mounted, and with them the lives of 10-man crews. For commanders in the Southwest Pacific, it was an unsolvable equation of fuel versus lives. They were desperate for any solution, no matter how unorthodox. And in May 1944, an unorthodox solution was about to arrive. That solution arrived in May 1944 at the 5th Fighter Command Base in New Guinea. Officially, he was Charles Lindbergh, a civilian technical advisor for Vought, the company that built the Navy's Corsair fighter. But Lindbergh had his sights set on a different plane and a different problem. Using his unparalleled fame, he secured a meeting with Colonel Charles MacDonald, commander of the 475th Fighter Group. In that meeting, Lindbergh laid out a proposal that bordered on heresy. He argued that to maximize range, pilots needed to unlearn their training. Instead of high RPM and a rich fuel mixture, they should do the opposite. Drastically reduce engine revolutions to as low as 1,600 revolutions per minute and lean the fuel mixture to the razor's edge of engine failure. To the combat-hardened pilots, it sounded like suicide. This was the textbook method for causing detonation, overheating, and stalling an engine, a death sentence hundreds of miles from home. But Colonel MacDonald was desperate. He weighed the enormous risk of trusting a controversial civilian against the certainty of losing more crews under the current doctrine. he made a command decision that could have ended his career. He authorized Lindbergh, a non-combatant, to fly a P-38 Lightning. The mission: prove his theory. The order was explicit. He was to test his methods, but under no circumstances was he to engage the enemy. With Colonel MacDonald's guarded approval, Lindbergh began his work not in a lecture hall, but in the cockpit of a P-38. He flew alone, a solitary figure climbing into the Pacific sky, armed not with guns, but with a kneeboard and a stopwatch. He treated the fighter not as a weapon, but as a laboratory. For days, he conducted meticulous, methodical test flights. He would push the Lightning to its operational ceiling, then begin a series of precise measurements. The flight manual and the instincts of every pilot in the 475th screamed for high RPM to keep the engines responsive. Lindbergh did the opposite. He throttled back. He methodically reduced the propeller revolutions from the standard 2,600 to 2,400, then 2,000. He kept going, pushing into what pilots considered the danger zone. 1,800 revolutions per minute, then an astonishing 1,600. Simultaneously, he began to lean the fuel mixture, starving the engines of gasoline, degree by painful degree, listening intently for the telltale cough of pre-ignition that signaled an engine was about to fail. On his knee pad, he logged every detail: manifold pressure, airspeed, and, most importantly, the gallons per hour reading on the fuel flow meters. When he landed, the data was undeniable. His calculations, refined over hours of solo flight, showed a potential increase in range of over 500 miles. He had proven his theory on paper, but convincing the men who flew these planes into combat would be another matter entirely. Data wasn't enough. He needed to earn their trust. Lindbergh began flying alongside the group's most respected pilots on routine patrols. One of them was Major Thomas Maguire, a fierce and aggressive ace already on his way to becoming a legend. On these flights, Lindbergh would match Maguire's heading and altitude, but fly the P-38 his own way. While Maguire's engines roared at 2,600 RPM, Lindbergh's hummed quietly at 1,650. The other pilots watched, skeptical, but then they saw it. Lindbergh's Lightning kept pace effortlessly, a ghost in their formation. After hours in the air, when they returned to base, the ground crews would report the fuel figures. Maguire's plane would be nearly empty. Lindbergh would land with hundreds of gallons to spare. The sight of his fuel gauges, stubbornly high after a long-range flight, was more convincing than any chart. Word began to spread through the barracks and briefing rooms. The impossible was happening. The aces, men who trusted their lives to their instruments, started to believe. Soon, pilots in the 475th began experimenting with what they called the Lindbergh cruise. On escort missions, once clear of their base, they would throttle back, lean their mixtures, and watch their fuel consumption plummet. The results were immediate and transformative. Their effective combat radius, the distance they could fly out, fight, and return, grew dramatically. Missions that were previously one-way trips for the bombers now had fighter cover from start to finish. The official range of the P-38 was about 550 miles. With Lindbergh's techniques, pilots were now confidently planning and executing missions over 700 miles out, an increase of over 30%. For the first time, they could escort bombers all the way to the formidable Japanese naval base at Balikpapan on Borneo, a target previously thought to be far beyond their reach. The tyranny of distance was beginning to break. This shift did not go unnoticed by the enemy. Japanese intelligence and coast watchers had years of reliable data on the P-38's operational range. They knew, with near certainty, how far the fork-tailed devil could fly. Suddenly, that certainty evaporated. American fighters were appearing deep in supposedly safe territory, strafing airfields and supply depots hundreds of miles beyond their known limits. Initial reports from Japanese pilots and anti-aircraft crews were dismissed as errors, misidentifications, or exaggerations. But the reports kept coming. P-38s were not just showing up, they were loitering, staying over targets for far longer than their fuel tanks should allow. The confusion in Japanese command posts turned to alarm. Were the Americans using a new model of the P-38? Did they have secret forward airfields they didn't know about? They were forced to pull back assets and scramble fighters to defend areas they had considered secure, stretching their defensive perimeter thin. A single civilian's knowledge of engine mechanics was now having a direct, strategic impact on the enemy's war effort. For Lindbergh, however, theory and instruction were not the final proof. He felt he had to demonstrate that these fuel-saving techniques worked not just on a quiet patrol, but under the stress and chaos of actual combat. And so, he began to cross the line. He started flying on combat escort missions, a direct violation of his civilian status and Colonel MacDonald's explicit orders. He was no longer just an advisor. On July 28, 1944, during an escort mission near the island of Ceram, the line was erased completely. The formation spotted a Japanese Ki-51 Sonya, a slow, single-engine observation plane. Lindbergh, flying in perfect position, peeled off and engaged. In a brief, decisive pass, he opened fire. The Sonya spiraled into the sea. Charles Lindbergh, a civilian technician, had just become an unofficial and illegal combat ace. The news of a world-famous civilian shooting down an enemy plane in a restricted war zone could not be contained in the jungles of New Guinea. The story began its inevitable journey up the chain of command, a ticking time bomb aimed directly at the careers of the men who had sheltered him, and at the highest levels of the government in Washington. But the story of this revolution wasn't about a lone genius. The principles of what engineers called economy crews were already known back in the United States, buried in test data from engine manufacturers and flight test centres. The real failure was institutional, a communication gap between the engineers who understood the theory and the combat pilots who were never taught the complex, counterintuitive techniques. Lindbergh was the human bridge, translating abstract data into battlefield procedure. But as news of his illegal aerial victory travelled 8,000 miles to Washington, that bridge was about to be burned. The report landed on the desk of General Henry Hap Arnold, the head of the entire US Army Air Forces. Arnold was furious. To him, the tactical advantage was nothing compared to the political catastrophe if the world's most famous isolationist was killed or captured. An urgent, angry cable was fired off to General George Kenney in the Pacific. The order was blunt and absolute. Lindbergh was to be grounded from all combat flying, immediately. The technique was proven, the pilots were convinced, but its champion was being forced out. Was there time for one last, decisive mission to cement its legacy before he was sent home? Before the grounding order could be fully enforced, there was time for one final, monumental flight. On August 16, 1944, Lindbergh joined an escort mission that embodied the entire purpose of his time in the Pacific. The target was the heavily defended Japanese oil refinery at Balikpapan, Borneo. The mission was a staggering 1,600-mile round trip, one of the longest fighter escort operations attempted by any air force in the war. This was not a story of dogfights, but of pure endurance. The vast formation of B-24 bombers and their escort of dozens of P-38’s was a flying testament to Lindbergh's methods. Every single pilot in that formation was now using the low RPM, lean mixture cruise technique. An operation of this scale and range would have been unthinkable just 3 months prior. Lindbergh flew with them, a civilian witnessing his controversial theory become standard war-winning doctrine in real time. He watched as the P-38’s shepherded the bombers over the target, their fuel gauges holding steady, their engines humming efficiently for hour after grueling hour. The raid was a stunning success, crippling a vital source of enemy fuel. It was the ultimate vindication, a strategic capability proven on the largest possible scale. And for Lindbergh, it was his swan song. His time in the Pacific was over. The man was sent home, but the knowledge remained. So we return to the mystery that began this story. Why Charles Lindbergh? He did not invent the principles of economy crews. That knowledge already existed, locked away in engineering reports and test pilot data back in the United States. The problem was a communication chasm between the engineers who knew the theory and the combat pilots who needed it to survive. Lindbergh was the human bridge across that gap. On the subject of flying long distances, he possessed a unique, almost mythical authority. He was the hero of 1927. When he told a combat ace his training was wrong, that ace listened. He was the catalyst who translated cold data into a life-saving combat reality. These techniques became standard procedure, enabling the long-range, island-hopping campaigns essential to defeating Japan. His contribution wasn't a single invention, but the crucial act of transferring knowledge under fire. To win the war against the Pacific Ocean itself, the US Army Air Forces had to learn an entirely new way to fly. They found that knowledge on the front lines, taught by the one man their own government had officially forbidden them to trust.